Okay, tell me one more time, what's the special word? So, soa, right? And the O and A stands for what? Or the O and the H? Opposite over hypotenuse. Cosine. Adjacent over hypotenuse. Tangent. Now we weren't supposed to spend the first half of class going over questions like 1 and just 1. But we did, so we're skipping them. Are you okay with that? Do you feel okay labeling it? O, always across from the theta. H, always across from the 90. A, my missing one. Is that okay? And what do you do one more time? If you don't have a side and you need it? Pythagorean theorem, yes. Pythagorean theorem. So, now we're going to go one step further and we're going to take that trig ratio and find missing sides. So right now we're just focused on the missing side. We're going to start just like we did before. If I want to figure out how big x is, could I use the Pythagorean theorem this time? No, I only have one of my sides, not two, right? But if I know what angle this is, I could find the missing side using trig. How I start these problems is very similar to how I start the ones above it. The difference this time is I have a number right here instead of a variable, right? We're going to use that number to help us. But very quickly, everybody needs to have a calculator. Do you all have one? If not, go grab one. I want you to practice on the calculator that you will be using on the test. Because on test day, if you don't know how to use my calculators, I can't show you. It's time for you to show yourself. Yeah. You need a calculator. They're $15, or those were $1 at the dollar store. $1. Okay, based on that angle, what is this side right here? The x is the what? O. The 13 is the what? Adjacent. So this time you yourself have to decide if O and A, is that sine, cosine, or tangent? So I'm using O and A, which one of those three is it? The tangent. So here's how I would set up this problem. I would say the tangent, now everything I've done so far is I put a variable here, right? But in this case, I don't need a variable because I know how big the angle is. 39.6. Tangent of 39.6, tangent of my angle is opposite. How big is the opposite side? X over adjacent 13. Now this right here is your variable you're trying to solve for. In this case, I don't just stop there and say my ratio, I'm done. I need to solve for x. So right now it's x divides 13. We have to cancel the divide 13. How would you do it? You would multiply by 13. Those cancel, and x equals whatever 13 times the tangent of 39.6 is. So we have to figure out what that is. Now, very quickly, let's talk about angles. We can measure angles in two different ways. One is by the degree, which is what we've been doing. One is by a radian, which we won't have done yet. So on your calculators, if you're using your phone, you're using your phone as a calculator instead of on your side, you get scientific, right? There should be, so right here, if you push the radian button, right there it says rad. We want to make sure it says nothing. If you're using this kind of a graphing calculator, you know? So on a graphing calculator, go to mode, screw down, it should say radian degree. The standard for whatever reason is radian, but the default, switch it over to degree, and hit enter, and then you can put out and down your degree. If you're using a scientific calculator, there's a degree button right here next to the second button. On the bottom, it should say degree or radian. So here, let's just practice really quick and make sure there's an easy way to tell. There's an easy way to tell if you are in radian or degree. Would this work? You think? On your calculator, will you type in sine of 30? Let's see what we get. Did anybody not get 0.5? Because if you didn't get 0.5, that means you're in radian. So let's fix it. What do you think? 1/2. Here we go. Anybody else? Anybody else want to get 1/2? If you didn't get 1/2 originally, try it again, make sure you do. Now, if you have one of my geeky little calculators, you can't put sine and then 30. What do you have to do? At 30 and then sine. So how you calculate these is going to be a little bit tricky if you have one of the backwards ones. It just takes a little bit of getting used to. Okay, so are we all in degree mode? We're good now? Let me show you how to plug this into the calculator. If you have a scientific calculator or a graphing calculator, all you have to do is type 13 times the tangent of 39.6 and you push enter. If you have, raise your hand if you have a backwards calculator where you'd have to do sine and then 30. Here's how you would plug this into the calculator. You would plug in 13 times 39.6 tangent equals. That's how you would plug it in. If you didn't, I'm going to pause this really quick. We're just going to make sure you all got 10 points. Should I maybe turn my light back off? Part B. Thank you. What do I do very first? Do the same thing over and over again. You start with marking your angle, then what? Label your sides. The 14 is the what? Opposite. You go through the triangle to get to the x. The 14 is the what? Hypotenuse. Now looking at your sales card, tell us which one uses O and H. Sine. So here's how I'll set up this problem. The sine of 60. Sine stands for what? Opposite over hypotenuse. Opposite is x. Hypotenuse is 14. Now my goal is to get x by itself. Right now, the number interfering with that is the 14. How do I get rid of the 14? Multiply both sides by 14. Now you could kind of look at this like a cross multiply problem if you wanted to. If I put a 1 underneath that and I cross multiplied, it would be 1 times x would just be x, right? And if I cross multiplied over here, wouldn't it still be 14 times the sine of 60? Yeah. The idea of cross multiply might help us if I can go around the bottom. And I'm sure we'll get there in just a minute. So on your calculator, let's see if we all can get the same thing this time. 14 times the sine of 60. What is it? 4.1? Yes. 4.1. Here's what you want to do then. This point right there. And then put this up on that. Okay. That's because it's so cool with the reading. I never can remember. Opposite? This is the what? Adjacent? Sine, cosine, or tangent? Tangent of what? Tangent of 62. How do I know it's tangent? It's my O and my A. Tangent of 62 is what over what? Opposite? This is the first time x is in the bottom, right? What am I going to do if x is on the bottom? Yeah, let's set it up like a cross multiply problem. So if we cross multiply, we'll just put a 1 underneath there. Change. If I multiply those two, what do I get? X times the tangent of 62 equals 3. Is that okay? If x is ever on the bottom, it's going to take one little additional step because right now x is still not by itself. Agreed? Right now x is being multiplied by a tangent. How do I get rid of that multiply? Let's divide by the tangent of 62. Now, if you have one of the straightforward calculators, you just plug it in and you're done. If you don't, this is how you plug it in. 3 divide 62 tangent equals. Don't forget to push the equals button. What did you do on that one? What is it? 1.5? 1.5 what? Yeah. Now this does bring up a good point. If you would have put 1.5 and I put 1.6, tomorrow I would read 1.6 as the correct answer, right? Do you mark it wrong? No, it's close enough, that's fine. If I put 1.6 and you put 1.2, then yeah, that's too far away. But on all of these, we're going to get decimals almost every single time, and they just have to be really close. To the cosine, very good question. It's all based on what you're given. So like on problem D, it's based on the angle that you're given. And then how is the 6 and the x? Where are they, their position in with regards to the 42? Yep. Good. And then we go to our SOHCAHTOA. Which one of those uses AH? Cosine, right? So that's how I know it's cosine. This cosine is the only one of the three that uses A and H. So finish that one up. Try part D and try part E. And let me know if you have questions when we walk around. Fun, right? Okay, this is fun, right? Yes. If you don't, just lie. Yes, right? Love it. This is learn things. I love it. Now, based on the 42 right here, your O and your A here. Your O. If you don't really cut it out because you don't know the time, and then the other two with your A. Now, we don't care about the O, we don't care about the T. So we're not going to do this. So we're going to do based on the angle and where they are, in relation to those two. So from there, let's try this one. That's your angle. we said cosine, right? Cosine what? Cosine is 42. Always of your angle. Now I know I'm using cosine because I've got the A and the H. Cosine is the only one that uses AH, right? It's the part of SOHCAHTOA. So is it 6 over x or x over 6? Ooh. It's AH, SOHCAHTOA. Now x is on bottom, so let's think of this as a cross multiply problem. So I've got x cosine of 42 equals what? 6. X times the cosine of 42. How do I finish this off? How do I do x by itself? Let's divide by the cosine of 42. Now really quick look, we're looking for a hypotenuse, right? The side we know is 6. So if my answer is 4 point something, did I do something wrong? Yeah, because it has to be bigger than 6. I know it's bigger than 6 because I'm looking for a hypotenuse. What's 6 divided by cosine 42? 8.07, 8.1, anything like that. Who got that? Feeling pretty good about it, I hope? Okay, let's keep going. Part B. Based on the 859. The 6 is what? Opposite. The x's adjacent, sine, cosine, tangent. Good. Tangent of 59 equals what over what? Opposite over adjacent, 6 over x. You have x on the bottom. Again, make it into a proportion because all of the ratios are proportional. 6 equals x tangent 59. Now what? Sorry, that's kind of smushed already. Again, are we looking for a number bigger or smaller, or is it really hard to tell at this point? It looks like it's smaller based on the picture. I can't guarantee that it will be though, because it's not a hypotenuse. What is it? What questions do you have on this process? How do you feel about it? You love it, I know, right? Yes. No square roots. Nope. Any other questions? There will be coming a time where you have to, like, your variable is going to be inside the tangent, and you have to figure out how to do that one, but no square roots. Okay, let's move on then. That's okay? To find the measurement of an angle, so everything we've done so far is finding a missing side, right? Now I'm going to practice finding a missing angle. Now every function, or every operation has an inverse operation. Every function has an inverse function. So if I were saying that the inverse of add would be what? Subtract. And the inverse of multiply is, good, the inverse of squared is square root, which we don't care about. The inverse of, well, the operation has 2 p's. That looks weird. It does, for real? Oh. If you're wrong, I'm blaming. I really don't think it does. Oh, thank you. Oh, that just looks really funny. Operation? That looks funny too. Hold on. I know how to solve this. Yeah, just one. We're good. Oh, that's not your hand. There we go. So if I were doing something like x over 6 equals 9, I have to do the inverse operation of the divide to cancel the divide, right? If I was doing an x squared equals 9, I would have to do the inverse operation of the squared to cancel the squared. If I want to do the inverse operation of sine, cosine, tangent, they are called arc sine, arc cosine, and arc tangent. Or, well, and then the arc sine is written like this. It kind of looks like a negative exponent. The arc cosine and the arc tangent would be tangent You can skip the arc sine, arc cosine, arc tangent if instead you would like to label or call them sine inverse, cosine inverse. Like that's not what I'm going to put on my paper, it's just what I'm going to say out loud. So I don't really use the words arc tangent, I say tangent inverse. Like that's how it's read. You can read it this way, arctangent, or you can read it this way, tangent inverse. I won't ever say tan -1. I might remind you that it's the -1 thing, but I'll say tangent inverse. Okay, and we're going to do this when I'm trying to solve for my variable. So if I'm just solving for a side, I'll put up a proportion, cross multiply, solve for x. If I'm trying to solve for a missing angle, it takes one extra step. Let me show you. Okay, note really quick. -1 is not the exponent. It is the notation for the inverse trig function. To calculate the angle measures using inverse trig functions on your calculator, so you have a button right here. On the button, it should say sine, and then usually up in like blue, it says sine -1. So if I want to find the sine of 60, I just push the sine button, right? I'm going to find the sine of 60. So you would do the second sine button, and you would get the inverse button. Okay. So let me show you how to do this. First thing, notice now I'm looking for the angle. I'm not looking for a side. So anytime you're looking for an angle, you have to use an inverse function to get it. Let's set it up though, right after trig ratio. The 6 is the what? The 9 is the hypotenuse, which is my 3, so Katoa uses OH. So, which would be sine. So the sine of theta, that ratio is what over what? 6 over 9. Now I'm not saying like the sine times x. There's no multiplying there. The sine and the theta are like merged together. The only way to unmerge them is to do the inverse of sine, which looks like this. Here's how I write on my paper. If I do the sine inverse, what it looks like, to this side, the sine and the sine will cancel and you're left with theta. You've unlinked that ratio. But if I do the sine inverse on one side, what do I have to do on the other side? The sine inverse. So on your calculator, here's how I plug it in. Sine inverse, you use that second sine button, and then plug in 6 divided by 9 equals what? So you'll do 6 divided by 9 equals, and then sine. Anybody else get 41.8? Now, what kind of measurement is it? It's a degree, right? So on this one, I want you to put a degree symbol. On the previous ones, I didn't have to because I didn't know how big, like it didn't tell me, right? It didn't say that this was 6 meters or 14 meters. There were no measurements. If there is a measurement there, I want you to put it, like feet or whatever. But there wasn't. On this one, I know it's a degree, so please put the degree symbol. Any questions with getting the 41.8? If you're doing it on that calculator, this one's the backwards one. Here's what you would plug in. You would say 6 divided by 9, enter, to get a decimal. And then second, we'll give you the sign. Does that work? Anybody else need help? Okay, let's do it again then. Next time, we're going to spend an entire day on where this is used. Because you always sit in math class and you're like, where in the world am I going to use this? Well, my answer to that is always, I don't know, I'm not a fortune teller. I don't know how you will personally use this. But it is used in real life. And tomorrow, we will kind of practice. Let's look at tomorrow really quick. Keep going. Keep looking. Yeah. Does this give you like anxiety? I'm so happy. Here, hold on. I'll just do it here. Look at those. Every single one. Isn't it pretty? Oh, I'm so happy. This is like,
It's like the story.
okay, like not better than Christmas, but I love it. Okay. I knew that I'd get that response, which is why I made you look. Okay, let's keep going. My point, though, is this is used, and this is really kind of the first math that you've done that is very applicable to real life. My other response to when am I ever going to use this is, I don't know, I use it every day. I usually always get, well, you're the teacher. But you didn't think okay, I jumped ahead. OH. Is that okay? Sine, cosine, tangent. Sine? Sine of what? Will I ever do sine of 90? No. Please don't. Sine of 90. Never going to happen. Sine of what? Theta. Yeah. Sine of theta equals what over what? Opposite over hypotenuse, 4 over 5. Good. I have to cancel the sign. How do I cancel a sign? Good. Sine inverse. If I do the sine inverse to one side, I have to do it to the other side. So on your calculator, what's the sine inverse of 4/5? 4 divided by 53.1. Feel good about this. 53.1 what? If I missed that, let me know. I'm not in good practice. Okay, try the next one. I'll buy you with it. Well. But I can get my iPad for it, or you can give me a new packet. Part C, is that sine, cosine, tangent? Cosine. Cosine what? This is A, this is H. Cosine theta equals what over what? Really quick. Try to do cosine inverse of 13 divide 12. Let's pretend like you made a mistake and you switched those two. On your calculator, do the cosine inverse of 13 divided by 12 and tell me what happens. It says like a domain error is what it's saying, right? It freaks out, it says you can't do it. How come? Will cosine ever be more than 1? No, so if you put the 13 divided 12, you're saying cosine is more than 1, right? Can cosine ever be more than 1? No, that's why it kind of whips out on you. No, never. Puny. What's the one? Yes. For sine, cosine, yeah. But is that true for tangent? Smaller number is always on top? No, that's not true for tangent. So, I had somebody, oh, sweet child. I had somebody once try to do this, and they tried to do like the tangent inverse to cancel it. Can somebody please explain the problem in doing that? The tangent isn't the inverse for cosine. What's the inverse for cosine? Cosine. So, warning, don't do that. So those will cancel. What am I left with? Anybody need help getting that? Okay, rather than giving you time right now, I'd like to hurry and finish the notes. Let's jump past DES. I'd like to look at those last three. Because on your homework and on your, or last four, excuse me, on your homework and on your test, it doesn't have them broken out into sections. It has them all kind of mixed together. So you have to say, okay, on this one, what do I have to do? I'm looking for a side. I'm looking for side. So this time I'm looking for an angle. So you need to know what to do and when. So let's just do ABC, and then if you guys, if I feel like you're good, then I'll have homework time to do. Okay, looking at problem A, we start with this, right? Mark the angle. Now what? O is what? Good. 5 is? So you always start. Mark your angle, label your sides. It'll get really annoying, but I'll say it every single time. Mark your angle, label your sides. Now what? Sine, cosine, or tangent. Now you make the decision. Which of the three is it based on those markings? Sine. OH? OA. Sine of what? The angle, 26. Sine equals what over what? Right. Opposite over hypotenuse 5. Set it up into a cross multiply problem. 5 times the sine of 26 equals 1 times x. Can we just call it x? Do I need to do anything further, or can I just plug it into my calculator at this point? Plug it in. Because x is already by itself, right? I have to just plug it in. What did we get here? 3.1? Huh. That still doesn't look like a 2, I don't care. Now, does my answer make sense with regards to my problem? My answer should be less than 5, right? How do I know that it should be less than 5? Because it's hypotenuse. It is. Okay, I feel pretty good about it. 2.1. Okay, set up number B, part B. And then tell you something that okay, sine, cosine, tangent. Opposite. What's this one? Hypotenuse. Sine, cosine, or tangent? Sine. I think a lot of them are sine, actually. Sine of what? 69 equals what over what? Good. How do I solve that? Then what? Cross multiply. 36.5 equals x times the sine of 69. Is x by itself? No, so we keep going. Do what next? How do you plug that into your backwards calculator? 36.5 divided 69 sine equals, right? You always just switch these two if you're using a backwards calculator and you have to switch equals at the end. What do we get for x? 39. lot of 39s, but they were very like under your breath. Okay, we're good then. Okay, so how is this next one different though? On the next one we're trying to find not a side, we're trying to find an angle. But you start the process the exact same way. It's just how do I solve it that could be a little different. So, based on my theta, the 11 is what? So the 14 is? What's it going to be? Sine. Again. Sine theta equals what over what? Do I have to cross multiply anything this time? No. The theta is almost by itself. The sine and the theta are kind of merged together. How do you break them up? Inverse sine. Good. So sine inverse both sides. 59.7? 1.7. How do you know about it? You feel good? Ring is on? Yeah. One more time? Yeah. Okay. You have not a lot of time, but you do have 7 minutes. Those 7 minutes can do several problems. Please don't waste them.